This hit and run is about R and statistical packages. Well, about statistical packages, let's just take a look here. R versus SAS and Stata and some of the other alternatives. What do employers really want? They want adaptability. They want you to have the ability to go learn their systems, whatever they are, including the classic scenario where you come in on your first day of work and your employer says, "Hey, kid, we use Stata here. Take this manual and go learn Stata." Well, that's really not such a crazy thing. And it's not that hard if you already know a statistical package. This is not like Italian versus Spanish, where if you're studying Spanish and learning a few Italian words messes you up. It's not like that at all. You don't have to have any great intuition to use a statistical package. So it is really not that big a deal what statistical packages you know. What you really need is the ability to learn one quickly, and I'll have a little bit to say about that. Excel, R, SAS, and Stata. Let's just look at a brief comparison. First, there is the matter of cost. Excel has zero marginal cost in most offices because it's already installed on all the computers as part of Microsoft Office. R is free to download and they're free upgrades. And there are free packages that are written by the R community. Anything that R can't now do that people want to do very much, somebody's going to come along and write a package that will do it. And when they do, that package will be free to upgrade. SAS is very pricey, costs many thousands of dollars for the corporate installations, but it is free in the cloud for students, and I encourage you. It's just an easy thing to do sometime. Go get your free cloud account for academics for SAS in the cloud and learn how to do a little SAS. Stata is pricey, but it is a very good package. Excel is easy to use. We've already seen you uh, outline some data and you click a couple of boxes and you're doing regression analysis. R is hard to use. Make no mistake about it, it is hard to use. SAS has medium difficulty and Stata has medium difficulty. When you do a statistical procedure in Excel, it gives you comprehensive results. Just gives you a whole bunch of stuff without asking for it. And the same is true for SAS and Stata. If you do a regression, it gives you just about every statistic you would ever want. With R, you have to ask, or you have to install another package. The default output for R is really pretty slim when it comes down to it. Excel is carefully curated with little change. Microsoft really hears about it if there's a mistake in Excel, so they're careful about changing it and updating it in the statistical package. So it hasn't changed very much at all. Skip over to SAS. It is very carefully curated with slow change. We had a JMU student working at the SAS Institute. She was on the inside, and they're very careful about changing SAS so that the huge existing base of code will continue to work even as they add changes. Stata is also carefully curated in their slow change. With R, it's the Wild West. You know, the shoot 'em up Wild West of fiction. Anybody can propose a package to R. They do some vetting of it, but those packages have a really weird relationship out there. And if you don't have the right package installed, things don't work. And some packages don't work with newer versions of R. Let's look at the steps that you would use in any package. What you have to learn how to do is to install and start. You've got to invoke the program. Then you got to learn how to read data in, and then you've got to specify the dependent and explanatory variables. If you're doing a regression, you got to figure out how to make it run, and then how to gather and work with the output. Then you've got to learn its quirks. In SAS, you have to end every code line with a semicolon or you get an error message. Now, the SAS Institute long ago could have changed that interpreter to take out that bug, but it left it in. So one thing that people are doing in SAS users, they're forever going in and finding the place where they forgot to put the semicolon. With Excel, we saw in one of our examples, you have to let it know when you've got labels at the top of a column of data. You don't have to let any of those other packages know that. They already know that when they're reading it in. With R, you have to learn to deal with the swagger of the R community. Because out there in the R community, there are some arrogant coders that will, kind of shame you if you go on the forum and ask a question. And in fairness, it is also true that out in the R community, there are some kind souls that are just waiting to help you with your problem. So, just to illustrate the steps in using any package, I want to use our quick start guide just as an example. And we'll have more to say about that. But in this connection, remember, you have to learn how to install and start. So, you got to do that with R. To read the data in, you put it in from an Excel worksheet. This is just in that Hello World program. You have to learn how to save it into CSV or some other format that R will read. CSV is probably the least troublesome and probably the most widely used. Then you have to figure out how to specify the dependent and explanatory variables. And in R, it just comes in this linear model statement where we use that little squiggle, that tilde, to tell it that Fahrenheit is the dependent variable and Celsius is the explanatory variable. And then you have to learn how to run. We're going to highlight the code and click run up there. And then to gather and work with the output. Look at this standard regression output. To somebody who's a veteran of SAS or Stata, this just looks primitive. It tells you the equation that it estimates, give you some information about the residuals that we don't pay a lot of attention to in econometrics. But here's the payoff right here, the coefficients, the probabilities that are involved there. And then it gives you those R squared figures for the goodness of fit, and then the F statistic for some statistics that you have to work with there. How do you work with that output? Well, one very straightforward way is to take that output and just type it into a table in Word. This is one way to do it. And I will tell you that packages, hey, there are those packages again, have been written for R that automatically give you beautiful output like this in any file format that you want. But you have to install and learn the packages. So my advice is if someone throws you a manual and says, hey kid, learn this statistical package, go do that hello world in a new package. Go convert some Fahrenheit to Celsius using the data that I've given you there. Just go run the quick start guide in a new package. When you do that successfully, you will know that you have learned how to install and start, how to read the data in, how to specify dependent and explanatory variables, run, gather, and work with the output, and you'll get a start on working with the quirks. And that is the hit and run on R and stat packages.